Okay, so this is 7th grade. We're starting 4-5. I just wanted to do a really quick review on factoring. I think you guys have done factor trees before. So starting with 12, if I wanted to find the greatest common factor between these two, I could use a factor tree. So I can just think of any two numbers that go into 12. Well, so for example, 2 times 6, that's 12. Now, I can't do any more factoring with the 2 because it's prime. But I can factor out 6, and I can do 2 and 3. So those are the factors of 12, 2, 2, and 3. You can do the same thing with 15, 3 and 5. And I'm done there. 3 is prime and 5 is prime. So what's the common factor, the greatest common factor between those two? Should be pretty obvious. It would be 3. All right, so you guys factor out 10 and 20 real quick. So let's see if you got it right. So 10, let me see here. I'll pull some sticks. Mr. Moore, what are the factors of 10 that you did?
I did 5 and 2.
Yeah.
And then
2
and, oh wait. No.
Go ahead, and then you can do 20.
20, I did 10 and 2.
Okay. I always, and it doesn't matter really. I always put the smallest factor on the left side. So 2 and 5 are prime. 2 is prime. 10 is not. What about 10?
You can do 5 and 2.
Yeah, 5 and 2 again. All right. So what are the factors that are common?
No, 5.
They both have a 2, and they both have a 5. 2 times 5 is what?
10.
10. Okay, so 10 is the greatest common factor between 10 and 20.
Oh, is this all we're doing?
No, not at all.
This is kindergarten stuff.
Is it? Then you should be able to do this one.
Yeah, we learned this in kindergarten.
Good.
Wait, what is?
So factor out 210 and 75.
Wait, what in? Oh, but dang. That made it harder, man.
Greatest common
That's
factor
harder.
would be 2. And the last one, because there's 3 2s.
10 is the greatest common factor between 10 and 20. It's the largest number that will go into both of them.
Oh.
Oh, Mr. Moore put up 100 points. All right, Mr. Meredith just pulled your stick. Factor out 75 for me.
25 and 3.
Okay.
And
3's
then
prime.
The 25 can be 5 and 5.
Okay. Good. All done. Put up 100 points. Mr. Scott, factor out 210 for me.
I mean, I got 2105. That was my first one. So like, sorry.
Wait, you got a 2 and a 5?
So, the
So
lowest
think of
one-
two numbers, if you multiply them together, would equal 210.
No.
So let's,
It would be
okay,
Two?
you said 2 and a 5.
no 2 and 105.
Because 105 plus 2.
Okay, so 2 and 105. I thought you said 2 and 5. Okay. Yeah. Now what?
Can I add points? So like point and stuff.
No. So we could factor this out from 2 and 105. I mean, 5 would obviously go into 105. But I'm just going to show you that I did it because I like to work with numbers that are easy to work with. Okay? So I just thought of 21 and 10. Multiplying 10. I'm just going to put 10 and 21. Okay? What are the factors of 10? 2 and 5. What are the factors of 21? 3 and 7. Okay? So that was a lot easier than I could have figured out. Again, Mr. Scott was right. We could have used 105, but I just like to use numbers that are easier to work with. So what are the common factors between the two numbers? 5. They both have a 5. What
I
else?
thought I raised my hand. 3.
A 3. Okay. And what's 3 times 5?
15.
So the greatest common factor between those two is 15.
So you just find the greatest common factor.
But
so
what
you
if you still have more?
multiply.
So it's like there's twos, there's 5s.
Does 75 have any 2s?
Other than the 2 and 5, no. No.
Okay. All done.
Because the 2
All done.
is 25.
All right. Now, you guys are going to be doing some factoring with variables. So let's look at the first one here. So it's 3x plus 12. And really, one way to look at this is you are using the distributive property backwards. So what's the greatest common factor between 3x and 12? 3. Okay, so I'm going to pull the 3 out, and I'll put x plus 4. You guys see it? 3 times x is 3x, and 3 times 4 is 12. Okay. Now, factor this one. We did that one. All of you do that one. 4x plus 9. How many have it? Raise your hand.
Got it.
Okay. Mr. Clarkey, what'd you get?
4, and then parentheses, x plus 5.
Sure enough. 4 times x is 4x. 4 times 5 is 20. Okay, good job. Put up 100 points. Now, everybody factor this one. Negative 2x minus 6. Miss Lamondola, you got it already?
No, I'm trying to figure it out.
Okay. Who's got it? Raise your hand. Oh, a few of you. Good. Let's see. Mr. Weiss, did you get it? No? Okay. Ms. Vasquez, did you get it?
So I got two parentheses negative x minus 3.
2, and then in parentheses, a negative x minus 3. Let's see if she's right. What's 2 times a negative x? Negative 2x. What's 2 times a negative 3? A negative 6. Nicely done. But there's another one that also works.
I know it.
Oh, put up 100 points. Mr. Proctor, did you get the other one?
Is it negative 2 and then in parentheses x minus 3?
Not x minus 3.
I know it.
It's x plus 3.
I did
But wouldn't
that.
it be negative 3 since the negative 2? Oh, no.
So negative 2 times x
Oh, I thought that
is a
I
negative 2x.
thought that 6 was a positive.
And then a negative 2 times 3 is a minus 6 or a negative
I thought
6.
that 6 was a positive.
Okay. All right. So those are several of the examples that the book gave you. So let's look at example 1. This is on page 222. And they just factored out 3x plus 12. And they did it visually. And then you just end up with 3, and then in parentheses, Mr. Scott, x plus 4. Okay? And then down at the bottom, the try it, 4x plus 20. We also did that one. You can fill those in. And they convinced me down at the bottom of the page, you guys can copy that down. It says use the distributive property to expand the expression. And then I just gave you an example here. Okay? And you can look at the try it. Again, there's a couple different ways to do that one. And I did one, and I want you to come up with another. So it was a negative 4x minus 28, and I put 4, and then in parentheses a negative x, and then a minus 7, or a negative 7, and that's going to be a negative 28. That's one way, so I want you guys to do another. Example 3, I'll let you look at that on your own. I'm not worried about the try it down here. You can scratch that out. Number 1, do you understand? It says expressions can be factored using the distributive property and the greatest common factor. And then down below 2a, it says explain any errors Susan may have made. And it would not expand to a negative 15b. Also, she subtracted 3 from 6. Again, it would not expand to a negative 15b. And she subtracted 3 from 6. Those are the errors that she made. And then b down below, it said to factor the expression correctly, and it should be 12a minus 15b plus 6. 12a minus 15b plus 6. And then I did these for you guys. Let's look at this for a moment, because you're going to have some problems like this. Let's look at number 3. Sahil, that's his name, is putting together supply kits and has 36 packs of X pencils. They're just calling it X pencils. 12 packs of Y crayons and 24 erasers. Then it says write an expression to show the total number of items. Well, 36X, because it's 36 packs of X pencils. So 36X plus 12 packs of Y crayons. So 36X plus 12Y. And 24 erasers plus 24. Then B says use factoring to show many kits. Use factoring to show many kits. I think it's supposed to be how many kits you can make while putting every type of item in each kit. So the greatest common factor between 36, 12, and 24 is 12, so I pulled that out. And then in parentheses, I put 3x plus y plus 2, because 12 times 3x is 36x. 12 times y is 12y. And 12 times 2 is 24. And then letter C, it says use factored expression to find the number of each item in each kit. It'd be 3x, 1y, or just y, and 2. Circle 4 and 5. So show me 2 different ways to factor those. Number 6 and 7, circle those. 8, 9, and 10. So for number 10, Mr. Scott, what's going on?
What? What?
Are you done?
Yeah.
Okay. Write 2 expressions. Number 11, circle that. Number 12, circle that. 13, just 13a. And 14b, factor the expression. This one here. Page 226, number 15. Write 2 expressions that give the perimeter of the pool. Looks like I wrote one. You've got to come up with another one. (16) Circle the expressions that have like terms. That's 16a. Scratch out 16b. I'm not worried about that. 17 I answered for you. It says Ryan says the expression 3 plus 5y cannot be factored using the greatest common factor. Is he correct? Well, yeah, 3 and 5 are prime. They don't have a common factor. And the 3 is not attached to a y. So the answer is yes, he's correct. (18) and 19. 18, there's 2, and 19, write an expression that is the product of 2 factors and is equivalent to a negative 2x minus 10. Okay,